This is lesson 3.3, proving lines are parallel. The warm-up, you've got 4 problems here. You're going to use the parallels with the transversals, and you're going to try to solve for the unknown variables. Do that now. So the answers to these, number 1, x is 100 and y is 40. Number 2, x is 90 and y is 30. Let's start with those. Does anybody have questions on 1 or 2? Brenna.
How did you get x is 100 and y is 40?
So let's look at number 1. We have 2 parallels cut by a transversal. That means that the 80 and the 2y are corresponding. So they are equal in size. So you have 2y equals 80. Divide both sides by 2, you'll get y is 40. So that means this angle is also 80 degrees. The x with the 80, those are supplementary. So we have 80 plus x equals 180, or x is 100. All right, anybody have questions on number 2? Number 2. Number 3, 60 and 130. Raise your hand if you need to see the explanation for number 3. So for number 3, you probably should extend out your parallels and your transversals. You have a parallel to the base, and you also have transversals that are in 2 positions. The sides of the triangles are your transversals. So I have the x and the 60. Those are corresponding. So those are both 60 degrees. I'll put that in my picture as well. So 60 here. Now if I move over to the other transversal, the y and the 50 are same side interiors. They are supplementary to each other. So 50 plus y equals the 180, or y is 130. Like that. All right, number 4, your answer is 110 and 55. Raise your hand if you need to see number 4. All right, so for number 4, you have 2 parallels cut by a transversal, but you'll notice the 2y and the x don't help you all that much because of the fact that they are corresponding. Now, you may have trouble with this because I forgot to put the other marking on this picture. Without it, you really can't solve it. And I had forgotten to do this. These were supposed to be parallel. And when that occurs, the x and the 110 are corresponding. So that's my fault if you don't have that information. But when you put the 110 in for the x, because these are congruent, these 2 are corresponding as well. So 2y equals 110, or you divide both sides and you get y is 55. So far we've talked about if you have 2 parallel lines cut by a transversal, you have corresponding angles that are congruent, same side interior angles that are supplementary, alternate interior angles that are congruent, alternate exteriors that are congruent. Today we're going to go backwards. We're going to talk about postulates and theorems that apply to finding out if lines are parallel. So let's look at these first ones here. The first one is a postulate. If you know that your corresponding angles are congruent, then by default, the 2 lines have to be parallel. You might remember we talked about the fact that if 2 lines were parallel, the corresponding angles were congruent as a postulate. You didn't have to do a theorem proof for postulates for corresponding because you can just measure those. But everything else is a theorem that we'll have to prove. Theorem 3.5, if the alternate interior angles are congruent, then by default the lines will be parallel. The next one, if the same side interior angles are supplementary, then the lines are going to be parallel. So the first one with correspondings we don't have to prove, but we can use correspondings to prove the other types. So we're going to start with a proof here. We have to prove one of the theorems. The theorem we're going to prove, if you have alternate interior angles that are congruent, then we're going to establish that the lines are parallel. Once we prove that, you can use it. But right now, we're going to have to prove it a different way. There's only one way you're allowed to prove it right now, and that's with corresponding angles. Do you have corresponding angles in this picture? We don't know they're congruent yet, and you can't say they are because we don't know these lines are parallel. So we have to find a way to get to the corresponding angles being congruent, and by default, those lines will be parallel. So in this picture, without even talking about correspondings or alternate interiors or anything else, is there a very basic set of angles that are congruent by something that's different? Laura? Yeah. 3 and 1 are going to be vertical from each other, and therefore they will be congruent. And from default then, we already know here that 1 and 2 are congruent, but can we say 3 and 2? Yeah, because of the way you've marked them. And because they're corresponding, the lines are parallel. So let's go ahead and look at the proof for that.
On the bottom it says,
Okay, so our proof, we have given that angle 1 is congruent to angle 2. And then we also said angle 1 is congruent to angle 3 because of vertical angles. So by default, we're going to be able to make a connection between 2 and 3. And why are 2 and 3 congruent? Not because they're corresponding, but because of what kind of algebra did we do here. So we've used substitution or transitive. You can use either one. Either one is fine. Notice they're both congruent to 1, so they're congruent to each other. Because 2 and 3 are congruent and they're corresponding, we can say these lines have to be parallel. And we're going to abbreviate this, okay? So it says, if the corresponding angles are congruent, the lines are parallel. So let's write it a little bit shorter. If core angles congruent, lines parallel. So that's the reverse of what we had written before when we were going the opposite direction. Because they are congruent and because they're corresponding, the lines are parallel. Because the corresponding is just a postulate, so we're allowed to use that. Now that we've proven alternate interiors, you're allowed to use it. If the alternate interiors are congruent, then the lines have to be parallel as well. So we're going to prove another one as well. This is another way to prove that you have parallel lines. It seems kind of obvious. In a plane, 2 lines perpendicular to the same line are going to be parallel to each other. So if T is perpendicular to both K and L, then K and L will be parallel. So we're going to go through that process of trying to prove that as well. The nice thing about angle 1 and angle 2 is they are corresponding to each other as well. So we can work at that corresponding idea. They tell you that K is perpendicular to T and L is perpendicular to T, and of course that's your given. We can also make statements about K and T though. Because of the fact that it's perpendicular, you can say a couple of things. You could say 1 and 2 are right angles. You could say they're 90 degrees. It's really up to you. Okay. Because we have 1 and 2 both equaling 90, are they equal to each other now? And that's what we want. The measure of angle 1 is equal to the measure of angle 2. By transitive property, you can also say substitution in this case as well. Since they're both equal to 90, cut the 90 out. Now, what type of angles are angle 1 and angle 2? They are corresponding. So we're going to be able to say, in fact, what I'm going to do is I'm going to switch over to saying that they're congruent here. So I'm going to say angle 1 is congruent to angle 2. So I switch from algebra to geometry because I can say that. If they're equal in size, then they're congruent just by definition of congruency. You do want to say that. And since they are congruent, the lines have to be parallel because 1 and 2 are corresponding. So if the corresponding angles are congruent, then the lines are parallel. And you can abbreviate that. So we're going back to the front of the paper for a minute because of the fact there's technically 5 ways to prove that you have lines that are parallel. And we've already talked about 3. The corresponding angles are congruent. Automatically by default, you have parallel lines, and that's a postulate. The next one, the alternate interior angles, 3 and 6, 4 and 5. If you can prove those congruent now, you can say your lines are parallel. Now the one we haven't done yet, which is part of your homework, the same side interiors are supplementary. If they're same side is supplementary, then you do have parallel lines. And we're going to be talking about, let's see, well, this one we already did. Number 4, both lines perpendicular to a third line. We just talked about that. If they're both perpendicular to a third line, they're parallel to each other. And number 5 is going to be something slightly different, and this one is actually in your homework, proving that lines are parallel to a third line. So if you have 2 lines where, let's say, I'm going to make this one a little bit bigger here. See if I can give it a different color here, so it's clearer. Let's do purple or blue. So if I tell you that the line above the blue line is parallel to it, and I tell you that the line below the blue line is also parallel to the blue line, are the 2 red ones parallel to each other? It's like a transitive property, but for parallel lines. So, and the way you actually prove this is with corresponding angles. Because what you can do is put a transversal line here. You can create a transversal wherever you want. And then, you get these out of the way here. And I'm going to make this a little bit exaggerated. But what you find is that the corresponding angles end up all being congruent to each other. So it's pretty easy to prove. So there are a few other theorems in your book. They may ask you to prove them. We're just going to briefly talk about them now. For a point outside of a line, there's exactly one line parallel to that given line. So you see I have a dark line with a point, and there's going to be one unique place that I can put this line such that it'll be parallel. And the way you would have to show that is drawing in some sort of a transversal and then proving a set of corresponding angles congruent. So that would be just by measuring. You can also do alternate interiors. Here's another one. Through a point outside of the line, there's exactly one line perpendicular. So I have my dark line with my point, and I can take this blue line that I have here, and there's one unique place that will pass through the line and the point, which is perpendicular. But it's also the same idea. You could measure here to figure that out. And the one that I already talked about was the 2 lines parallel to the third. You can add a transversal and prove angles that are congruent within the picture. All right, so I've got a couple of practice problems for you to do here at the bottom. So it says, can you prove lines A and B are parallel? And explain why or why not. There's only 5 ways to prove lines parallel. And I have them on the front here. If you can establish one of the 5, then you can say yes and tell me which one would allow you to do that. I also want you to do the 3 algebra problems at the bottom. Let's go ahead and take about 10 minutes to do those at the bottom, and then we'll check them. But, so for the first 3 pictures, the first 2 are both yeses. And I want to talk about number 3. What you have marked here are alternate exteriors, but alternate exterior is not one of the 5 ways to prove that you have parallels. However, this right-hand angle is congruent to the one below it by verticals, and by default, you have corresponding. So this is yes by corresponding angles being congruent. On number 4, these are also corresponding, so those are parallel by default. And number 5, you have alternate interiors, but they don't have a marked congruent. In fact, they made a statement. They said they were equal to 180, and that's not true. If the same side interiors are supplementary, but these are not same side interiors, they're alternate interiors. So the answers to the 3 pictures here. So AC and BE are parallel in that picture. X would have to be 50 to make those parallel. And over here, this is extremely familiar, isn't it? Well, X is 20 and Y is 30. That's just a variation on another problem that we have done.